Hello, now let's talk about multiple cash flows. So again, referencing the timeline, let's say months, just to change the time unit. If I'm putting the time unit in months, then my interest rate also has to be in months. Okay. So let's say my interest rate is 1% per month. And I'm expecting over the next couple of months to have the following net cash flows in my possession. Let's say I am expecting $800 at the end of the first month, then 700, then 750, and let's say by the fourth month I'm expecting $650. Actually, to make it even more exciting, let's say I'm expecting a net cash flow of negative $750 by year 3. So these are inflows and this is an outflow, and that's an inflow again. Positive cash flows, imagine as revenues, profits, and negative cash flows, a loss, something that it's getting out of your pocket. And for simplicity, let's say we have nothing at time 0. So my question is, given that I can put these in, let's say, a savings account that miraculously earns 1% per month, how much money will I be able to withdraw at year 4? So basically I'm saying, okay, this is going to be earning 1% per month. This is going to be earning 1% per month. Then 750 gets withdrawn, but I could have been earning, if that was positive, interest on that stuff. And then also I have this 650 here, right? So at the end, what is the future value? What is the future value? The summation of all these cash flows given the time value of money, 1% per month. So the future value, we know it's equal to the present value 1 plus the interest rate to the power of n. This is what I call the mother of all formulas. Mother of all formulas in our class. So if I want to figure out how much I'm going to have at the end of 4 months, basically I need to compute the future value of each one of these cash flows and then add them up. So in this case, the future value is basically equal to the summation of all future values. And therefore we're going to have $800. They're going to be earning interest for how many months? Not the full 4 months, because I am only expecting to have $800 a month from today. So these $800 are going to earn interest 1 month, 2 months, 3 months. So 800 times 1 plus the interest rate, which is 1%, to the power of 3 months. That's how long the $800 are going to be earning interest. Then what about the $700? Well, the $700, I'm just getting it 2 months from now, which means they're going to be there just 2 additional months earning interest. So the 700 are going to be there earning interest at 1%. Only for 2 months. What about the 750? Right? I lost that money, so it's going to get out of my investment, which means I'm losing potential interest that I could be earning from these amounts. So I need to take that into account. So the plus the negative 750, I'm missing 1 month of interest. So times 1.01 to the power of 1. And then by the end of the 4th month, I'm expecting to collect 650. This money is going to be there, even though I'm not going to earn any interest, because to earn interest we'll have to be there for an additional month, but I'm withdrawing all the money at this point. The 650, I'm going to collect it. If you want to be detailed, then this is the same as writing, following the same formula, times the interest rate to the power of 0, because there's no months that these 650 are going to earn interest on. Since this is equal to 1, then you could write just 650. So this will be equal to $1,430.81. So note that if you were to ignore the time value of money and just add these cash flows, and one way to ignore the time value of money, like a very simple example, would be to put the money under the mattress. So let's say you didn't put in your savings account. So if you were just to put it under the mattress, you would just add these cash flows, and these will add up to $1,400. But if you put it in the financial security, let's say savings account, that was earning 1% per month, then you'd earn interest of the extra, right? Is the $30.81 earned as a return of investing your money, in this example, in a financial security called savings account, right? The time value of money idea. Now, we just found out that the future value of these cash flows was $1430. So we just found out that the future value was 1430.81. What about the present value? Well, at this point, there's two options to compute this, right? Ignore that we computed the future value and find the present value instead. So let's do that option. Imagine you're just exposed to this situation, but instead of asking for how much money I'm going to have in the future, is the same as having how much money now. Okay? Let's say you approach an individual, or let's say you're one of your relatives, and say, hey, I really need cash now, and I'm expecting these cash flows in the coming months. I'm willing to give them to you and pay 1% interest if you give me right now a certain amount of money. How much would that be? So I'm asking pretty much for the summation of the present values of all these cash flows. So instead of pushing them forward, I'm going to push them backwards. Instead of pushing them forward, I'm going to push them backwards. So pushing them to time 0. Pushing them to time 0. All of them. And at time 0 there's nothing. That's why I'm asking the money for, right? So the summation of the present values would be so let's start with 650. I'll have to push it back 1 month 2 months, 3 months, 4 months. Okay. 650 divided by 1 plus the interest rate to the power of 4. Now let's say I want to take care of the 750. So plus the negative 750, and I have to push the 750 back 1 month, 2 months, 3 months. So 1.01 to the power of 3 plus the $700. I'm going to push them back 1 month, 2 months at 1% per month. And then the $800 just needs to be pushed back 1 month. And there's nothing. If there was a value here, we would simply add it up. But as there's nothing, we wouldn't need to write plus 0. I'm just writing it to reinforce that idea. So this would be 1374.98. If somebody would accept the deal of paying you now in advance to collect these cash flows and pay out this obligation, to earn a 1% return per month as a reward for saying yes to this, agreeing to this operation, then that person would have to invest now, or meaning give you $1374.98. So this was the present value, right, of these cash flows, and the future value, remember from a moment ago, was 1430.81. So this is how much money you would be able to withdraw at the end of 4 months, and this is how much money you would be able to get now for giving up to somebody else these cash flows and guaranteeing them a 1% return. Now let's say you want to figure out, okay, I have all these varying cash flows per month. What if I want to have a constant cash flow per month instead of having to deal with this variance? Well, that's a question we can solve with the next topic, which is called annuities. I'll talk about annuities in more detail in the next video, but I'm going to give you already an insight into it. So we know that these cash flows are expected to happen over 4 months, and that the future value is 1430 and the present value is 1374.98. Now I'm going to introduce you to two new formulas. Let's start with the future value. Annuities. The future value of an annuity is given by this formula, which is in page 19 of your textbook. Over there, as I mentioned in the syllabus video, we have a formula sheet, and this is one of the formulas. So if I know the future value as well, and the question is, what is the constant uniform amount that has the same future value as these varying cash flows situation? So if the future value is 1430.81, I want to find the annuity A, given that the interest rate is 1%, (4 months) minus 1 divided by the interest rate. So you solve for A equal to $352 $1.38. Okay. What this is basically saying is that having this timeline, or one where 0 times 4, and this is months, and what this formula just told us is that collecting 352, let's run to 38, otherwise it won't fit, $352 approximately per month has the same future value as having these cash flows per month. The difference is that these are uniform, constant. Sometimes businesses prefer financial securities that provide constant cash flows, because if there is one thing business do not like is uncertainty. So if we want to have constant cash flows, we still need to figure out, like we did, the future value, and then flatten out the cash flows using this formula, right? Which is basically an approximation of a finite series using the mother of all formulas. This comes from here. This comes from the mother of all formulas, 1 plus I. Right? And having a finite series up to n, right, of the summation of future values, it reduces to this formula. Right? For cash flows paid out at the end of every time period, right? There's nothing here, and then at the end of the first month, 352. At the end of the second, another 352, and so on for 4 months. Right? Is that what we call end of the period payments? Right? The period here is the time unit, end of the time unit payments, which is months. So at the end of the first month, 352. At the end of the second, at the end of the third, at the end of the fourth, and so on. Now let's say that instead of using the future value, you computed the present value, and you still have the same question. Okay, how much is the flat annuity equivalent to a present value of $1374? So you'll have to compute a finite series of present value formulas, right? Right, let's do this here. So the present value formula, remember, is just solving the mother of all formulas for P, and this would give an annuity of P is equal to A, 1 minus 1 plus the interest rate to the power of minus n. So for the sake of minimizing confusion, let's take this out of here. But it comes from the mother of all formulas. So here is minus n. Very important to note that this is a negative exponent, right, divided by I. It's a negative exponent because it used to be in the denominator, right? Now we push it to the numerator, and since it's coming up to the top, it has to be the inverse, so therefore minus n. So if you are to use this formula, the present value of an annuity formula, and you plug the present value of 1374.98, you're looking for the A, 1 minus 1 plus the interest rate of 1% over negative to the power of negative 4, because there's 4 months, divided by the interest rate. you would get the same result of $352. Okay, so regardless if you come from the present value approach or if you come from the future value approach, the annuity has to be the same. So this is how you transform a varying cash flow series into a constant time series